Quarter 2, Module 1, Exogenic Processes. Most essential learning competency, we have described how rocks undergo weathering, and we have learning objectives, describe the different exogenic processes that causes the earth to continuously change its surface, understand the effect of exogenic processes to human life. What is exogenic processes? It refers to activities or phenomena that occur on the Earth's surface. Exogenic processes is also called gradational processes, which comprises degradation and aggradation. When we say degradation processes, is also referred to denudation processes, which includes weathering, mass wasting, erosion, transportation, while aggradation processes, which include deposition. Deposition refers to various geomorphic agents such as wind, water, gravity, ice, associated processes, and resulting to depositional features like coastal, sea beaches and coral reefs, glacial. We have types of exogenic processes. 1. Weathering. It is referred to disintegration and decomposition of rocks, which merely produces regolith, eventually soil and sediments. The processes begin in microscopic spaces, cracks, joints, faults, fractures, lava vesicles, and other rock cavities. And we have 3 types of weathering. We have physical weathering, chemical weathering, and biological weathering. In physical weathering or mechanical weathering, this refers to disintegration and decay of rocks via weather elements such as high temperatures, extreme cold, and freeze-thaw cycles. This picture illustrates the physical weathering happens when rock is physically broken into smaller pieces. Water collects in rock. Water freezes and expands, forcing rock to widen. Ice thaws, contracts, and water gets deeper into crack again. A repeated expansion and contraction causes further cracks till rock splits. So there's no change in chemical composition of rocks. It merely due to thermal expansion, contraction, and or release of pressure when buried rocks are uplifted and exposed, which also refer to exfoliation. So there are certain factors that affect physical weathering. We have ice wedging, release of pressure, growth of plants, animals, abrasion, wherein sand and rock carried by wind, water, ice wears away surface rock when rocks collide, most commonly in windy areas. And there are some factors affecting physical weathering, which also includes into biological weathering. Another types of weathering, we have chemical weathering. It decomposes rocks through a chemical change in its minerals. There are several factors that affect chemical weathering. We have water. Water dissolves rock chemically. And we have the hydrolysis processes wherein igneous rocks have much silica, which readily combines with water. Oxygen, rocks that has high iron in it, mixes with oxygen and rust. The process is called oxidation, wherein important in iron-rich rocks gives reddish coloration like rust. And we have carbon dioxide, which dissolves in rainwater and weathers marble and limestone. The process carbonation and solutions, wherein the carbon dioxide dissolved in water reacts with carbonate rocks to create a soluble product known as calcium bicarbonate. And then other several factors are living organisms and acid rain. Biological weathering. Plants and animals contribute to weathering. physically break or wedge rock, lichens, algae, and fungi living organisms remove minerals and weaken rock by releasing acids, burrowing animals, which also can increase weathering. Another types of exogenic processes is mass wasting. It is the process whereby weathered material is moved downslope under the immediate influence of gravity. We have different kinds of mass wasting processes and classification based on speed of movement, kind of earth material involved, and kind of motion involved. So we have soil creep or a downhill creep caused by varying agents like worms, ants, and the like, where the material is in soil and it is slow in movement. We have slump, a downslope curved shear surface in underlying rocks. The materials is in soil or debris. There's a slow or fast in movement. And then we have a slide, a landslide, a mass of soil sliding down a hillside. It is a movement of a mass of rocks or debris or earth material down a slope. So the material, of course, the rocks or debris, wherein the speed is in fast or slow in movement. We have flow, we have the rock flow, and we have also the mud flow. When we say the mud flow, it involves a very rapid to extremely rapid surging flow of debris that has become partially or fully liquefied by the addition of significant amount of water to the source's material. And this speed can either be rapid and surging, and while in the debris flow, it can either be slow in movement. And then we have avalanche. It is a rapid flow of snow down a hill or mountainside. Certain locations are naturally more dangerous than others, like during winter time, particularly from December to April, when most avalanches tend to happen. So the material, of course, we have the ice and snow, or can either be debris or rocks. Of course, it is in fast or in rapid in movement. And we have fall. We have fall, which is a rock fall, which involves the dislodging and rapid downslope movement of individual rocks and rock masses. In a rock slide or debris slide, the material that is falling is sliding down a slope, whereas in a rock fall, the material, which is rock, is falling from a cliff face. So the speed, of course, is in fast in movement. And this is some of the classification of mass wasting. We have soil creep, slump, debris slide. We have debris flow, mud flow, earth flow, solifluction, and rock fall. When we say solifluction, it is a soil flow, the slow flow of saturated soil down a slope. 3. Sedimentation. It is the accumulation of materials such as soil, rock fragments, and soil particles settling on the ground, usually occurs in streams or sea erosions. Over time, the sediment load becomes thick and forms a new layer of ground. And then we have the process of sedimentation, wherein the eroded sediments end up in the water and begin to settle. That is sedimentation. With time, more layers pile up and presses down the lower layers, which is known as compaction. More layers, like known as strata, and further compaction forces out water of the layers, and the salt crystals glue the layers together, which is known as cementation, and these rock masses formed as sedimentary. 4. Erosion. It is the process by which natural forces move weathered rock and soil from one place to another. Deposition is the process that follows erosion. Erosion is the removal of particles from a landscape, usually due to rain or wind, and then deposition begins when erosion stops. The moving particles fall out of the water or wind and settle on a new surface. So sediment is created through the process of weathering, carried away through the process of erosion, and then dropped in a new location through the process of deposition. And we have four agents of erosions. We have erosion by water, by wind, by ice, and by gravity. And this is the diagram of exogenic processes. We have weathering, mass movements, erosions, and depositions, which also includes the sedimentations. So under weathering, we have three types of weathering: physical, chemical, and biological weathering, which includes all the factors affecting the types of weathering. And we have here the mass movements, which includes slow mass movements, which refers to soil creep and solidification. And we have the rapid mass movements, which includes earth flow, mud flow, debris, avalanche, landslides, which also includes slump, debris slides, and rock slides. And we have the erosion, which is the removal of particles due to the agents of erosions. And we have deposition, wherein the deposition is the process that follows erosions, wherein the dropping of sediments by wind, water, ice, or gravity, same as the agents of erosion. And we have sedimentations, where it usually occurs in streams or sea erosions, wherein the accumulations of materials such as soil, rock fragments, and soil particles are settling on the ground. How does the exogenic processes affect the Earth? Exogenic processes are very destructive. These processes takes place near the Earth's surface that makes the surface wear away. But of course, they are responsible for degradation and sculpting the Earth's surface. How do the exogenic processes affect humans and the environment? One of the types of exogenic processes is mass wasting that has drastic effects on human and animals' life in the form of landsliding, earthquakes. So deposition is which sediments, rocks, and soil are added land mass. Its positive effect is that it creates new land, and the negative effect is which is it takes away a new land. Quarter 2, Module 2, Inner Earth. The most essential learning competencies are: explain why the Earth's interior is hot, describe what happens after magma is formed. So we have learning objectives: describe why Earth's interior is hot, and describe what happens after magma is formed, and explain how magma became igneous rock and its economic importance. What is endogenic processes? It is the geological processes that occur beneath the surface of the Earth, and it is associated with energy originating in the interior of the solid Earth. Internal structure of the Earth. The internal structure of the Earth is divided into major components. We have an outer silicate solid crust, which thickness varies from 30 to 40 kilometers under continents to 7 to 10 kilometers under the ocean. Then, a highly viscous asthenosphere. It is a hot mobile layer of partially molten rock, and a solid mantle, which is mostly a solid layer between the crust and the Earth's outer core, a liquid outer core whose flow generates the Earth's magnetic field. It is a fluid layer mainly consisting of iron and nickel, and the solid inner core, which is the solid hot spinning metal ball that is the densest part of the Earth. The inner core is believed to be solid due to tremendous pressure surrounding it. Some seismic waves increase in velocity when passing through the inner core. The inner core has the highest density of all zones within the Earth. It is theorized that the inner core is also composed of iron and nickel. Types of endogenic processes. We have tectonic movements, also known as diastrophic movement, and also called as tectonism. It is a large-scale deformation of Earth's crust by natural processes, which leads to the formation of continents and ocean basins, mountain systems, rift valleys, and other features by mechanisms such as lithospheric plate movement. The Earth is made up of roughly a dozen major plates and several minor plates. The Earth is in constant state of change. The lithosphere consists of 15 to 20 moving tectonic plates. Okay, we have kinds of tectonic movements, and we have the major plate tectonic boundaries. We have the transform plate tectonic boundaries, divergent plate tectonic boundaries, and convergent plate tectonic boundaries. So in the transform plate tectonic boundaries, this is the places where plates slide sideways past each other, like what the pictures illustrate. The transform boundaries lithosphere is neither created nor destroyed. Many transform boundaries are found on the seafloor, where they can connect segments of diverging mid-ocean ridges, and one of the example of transform boundary is the California San Andres Fault. And then we have divergent plate boundaries, wherein this is the linear feature that exists between two tectonic plates that are moving away from each other. And the divergent boundaries within continents initially produce rifts, which eventually become rift valleys. And then we have convergent boundary. This is also known as destructive boundary. This is the area on Earth where two or more lithospheric plates collide. One plate eventually slides beneath the other, a process known as subduction. The subduction zone can be defined by a plane where many earthquakes occur, and that's the type of plate tectonic boundaries under kinds of tectonic movements. 2. Volcanism. It is any activity that includes the movement of magma toward or onto Earth's surface. Next, we have types of volcanism. There are two types of volcanism. We have the intrusive and extrusive volcanism. When we say intrusive, it is a magma cools, crystallizes, and solidifies into igneous rocks below the Earth's surface. When it cools, it becomes solid. While still underground, different features called plutons are formed. The rock formed is intrusive igneous rock. And then when we have extrusive Volcanism is wherein magma surfaces as lava and cools, crystallizes and solidifies to contact with air or the sea into igneous rocks above the Earth's surface. So, based from the illustration, the partial melting, which is the origin of magma rises, intrusions, and stagnations, and crystallization happens, and there is a differentiation of magma reservoir, and there is a extrusions of lava in the form of volcanic eruptions, and those volcanic gases are mixed with the atmospheres. Okay, magmatism. We all know that magma is the original material that make up igneous rocks, and magmatism happens when a magma is generated and develops into igneous or magmatic rocks. The process can take place either under the surface or on the surface of the earth. 4. Metamorphism. It is the process of changing the materials that make up a rock. Chemical components and geological characteristics of the rock change due to heat and pressure that are increasing or decreasing. So rocks changing due to weathering and sedimentation are not considered to have undergone metamorphism. And there are 4 kinds of metamorphism. We have regional metamorphism, dynamic, hydrothermal, and contact metamorphism. When we say regional, of course, it is due to extreme compressional forces required, dynamic due to crushing and grinding of rocks, hydrothermal due to interaction with a high temperature fluid, and contact metamorphism is due to around intrusive igneous rocks. 5. Seismic activity. It describes as the types, frequency, and size of earthquakes that happen over a period of time in a certain area. When the break line or fault, which is based from the illustration given, between 2 blocks of rock suddenly moves, the movement causes vibrations, known as seismic waves, to raise rapidly outward in all directions from the focus. We have here earthquake information focus, the point in Earth's interior where earthquake energy is released. Epicenter, the point on Earth's surface directly above an earthquake's focus. Is an earthquake more dangerous than a volcano? Earthquakes can cause damage by shaking, tsunamis, and landslides. Volcanoes can cause damage by ash flows, release of gases, mud flows, lava flows, and landslides. While most seismic activity related to volcanoes is not necessarily followed by an eruption, almost all eruptions are preceded or accompanied by earthquake activity at shallow depths in the vicinity of the volcano. Okay, we have here the diagram of endogenic processes. We have the slow movements, diastrophism, which is referred to tectonic movements, which includes the continental building or epherogenic, which includes the divergent plate boundary, and the orogenic mountain building, which includes the convergent and the transform plate boundaries. And we have the sudden movements, the volcanism, and the earthquakes. Why the Earth's interior is hot? The interior of the Earth is very hot. The temperature of the core reaches from more than 5,000 degrees Celsius for 2 main reasons: the heat from when the planet formed and the heat from the decay of radioactive elements. The Earth was formed by the process of accretion. This process accumulated a lot of heat When two objects collide, heat is generated. This heat has not dissipated totally and represents about 10% of the total heat inside the Earth. Another main source of heat is the decay of radioactive elements. Radioactive decay is a natural process, unstable like 238 uranium or 40K potassium, stabilize with time and produce what we call daughter products, 206 lead for uranium and 40 argon for potassium. This process produces heat which represents about 90% of the total heat inside the Earth. Formation of magma. So we all know that magma is a liquid rock produced under Earth's surface, and magma can form under three conditions. If the temperature of the rock rises above the melting point of the minerals and the rock is composed of, the rock will melt. If there's enough pressure and if there's addition of fluids such as water may also decrease the melting point of some minerals in the rock that causes the rock to melt. What happens after magma is formed? As magma moves upward, it pushes into or intrudes the overlying rock. Rock that falls into the magma will eventually melt. The rock may combine with the new igneous rocks, which is rock that forms when the magma cools. When magma does not reach its surface, the magma may cool and solidify inside the crust. This process results in a large formations of igneous rock called plutons. The small plutons called dikes and the batholiths are large plutons that cover an area of at least 100 square kilometer when they are exposed to Earth's surface. How does magma make igneous rocks? When the magma reaches the surface, it cools quickly, a matter of days or weeks. When the magma forms packets underground, it cools much more slowly. This could take thousands or even millions of years. The rate at which the magma cools determines the kind of igneous rocks that are formed. So based from the illustration, some of the intrusive rocks we have porphyry and pegmatite, and some of the extrusive rocks we have rhyolite and basalt. Economic importance of rocks. It is a fundamental building blocks of Earth. It is of various uses for modern economic development. It is important clues for the history of the Earth. And the igneous rocks, granite, basalt, gabbro, and the most important species used in the best way to carry big weights such as road constructions. Metamorphic rocks, marble, gneiss, and sea-stone is not suitable as a material for road constructions because it is weak, which is easily break. And sedimentary rocks, limestones, sandstones, and claystones use sandstones and dolomite in the construction of roads, and the limestone is also used in concrete to withstand the pressure. And sedimentary rocks are also significant in economic terms, being relatively soft and easy to cut. They are often used as the construction materials. Economic importance of igneous rocks. So we have, it is a great source of metal. Ores, granites, and basalts are used extensively as building materials. Basalts, whether to raipur or black soil, basalts also used as road material. So it makes up 90% of Earth's crust. Well, it occurs in all terrestrial planets. There's economic deposits like diamond, chromium, nickel, cobalt, molybdenum, tin, tungsten, titanium and lithium. And the occurrence, of course, is in the mantle, in the oceanic crust, in the continental crust, and specific rock types closely tied to tectonic setting. So igneous rocks are also very important because their mineral and chemical makeup can be used to learn about the composition, temperature, and pressure that exist within the Earth's mantle. They can also tell us much about the tectonic movement or the environment, given that they are closely linked to the convections of the tectonic plates. activity, make a concept map or diagram of geomorphic processes and answer the following guide questions. 1. What are the importance of knowing the geomorphic processes? 2. What causes exogenic processes? 3. Which important role does exogenic processes plays? Activity Sheet 1.2 Individual Activity. Answer the following guide questions. 1. What is the source of the heat in Earth's interior? 2. What would happen if the Earth's core cooled? 3. Why is it important to know, study about exogenic and endogenic processes? 4. How important these geological processes, geomorphic processes on Earth. And this is our references.